This is Jinwoo and Josh's lab. We will be conducting the jumping flame experiment. In this experiment, we will combust two wooden sticks, one which we will put out until it is just an ember, and leave the other as an open flame. We will have two flasks, one of which we will mix dry yeast and hydrogen peroxide to produce oxygen, and in the other flask we will produce carbon dioxide by mixing sodium bicarbonate, also known as baking soda, and hydrochloric acid. We will put the open flame into the carbon dioxide, simultaneously putting the ember into the oxygen. The carbon dioxide will then put out the flame at the same time as the ember, being lit by the oxygen, hence making it seem like the flame jumped from one stick to the other. We will be exploring the concept of combustion. There are three factors that contribute to the combustion. First, which is fuel, second, which is the amount of oxygen, and third, temperature. We hypothesize that at a specific temperature, when the fuel and the oxygen meet, there will be an immediate combustion that occurs due to the oxidation reaction that the oxygen goes under. Okay, so first off, we have these two flasks to produce the gases. We have these two wooden chopsticks that we're going to light on fire. We have hydrogen peroxide and dry yeast, which we will mix to produce oxygen. We also have 2 molar hydrochloric acid, which you can see now, and sodium bicarbonate, also known as baking soda, which we will mix to produce carbon dioxide. We also have these two weighing trays to weigh out the dry yeast and the sodium bicarbonate. So first off, we pour some sodium bicarbonate into one clean weighing dish, and then we put this baking soda into one of the empty flasks, one of the dry, clean, empty flasks. This is the flasks that will be producing carbon dioxide. We pour some more because due to previous experiments, we found out that mixing sodium bicarbonate and hydrogen chloride produces less carbon dioxide than the oxygen, which is why we used such a strong acid and more sodium bicarbonate than in previous experiments. Now we're having this dry yeast, which we measure out in the other weighing tray, the other clean weighing tray. And again, this will go in the other dry clean flask, which again we will be mixing to produce oxygen. We pour more to ensure that there's enough oxygen to ignite the ember, which was another problem that we encountered during previous trials. So now we're going to light these two wooden chopsticks on fire using a lighter. We're going to leave one of them in an open flame and then partially blow out the other one, just so as to leave the other one as a mere ember. So we blew out but left just enough flame for it to ignite later when we pour hydrogen peroxide into the dry yeast to produce oxygen. And now we're going to start mixing the two flasks. So again, the flask with the sodium bicarbonate we're going to mix with hydrogen chloride to produce carbon dioxide, and the flask with dry yeast and hydrogen peroxide will produce oxygen. And as you can see here, the flask with the baking soda and the hydrochloric acid produced enough carbon dioxide to put out the open flame. However, the flask with the hydrogen peroxide and the dry yeast reacted much more slowly than the baking soda. As a result, the production of the oxygen was much slower than the production of carbon dioxide. However, as we can see here, as time passes, there is more oxygen getting produced, which is the reason why the ember ignites back on fire.
Well, moving on to our conclusion, to make the flame seem like it jumped, we needed to make sure that oxygen ignite the ember while carbon dioxide put out the open flame at the same time. However, the reaction of the baking soda and hydrochloric acid happened much faster than the reaction between the dry yeast and the hydrogen peroxide, which meant that the carbon dioxide was produced quicker and faster than the oxygen. This is the reason why the flame was put out first, while it took longer time for there to be enough oxygen to ignite the ember after starting two reactions at the same time. The concept behind the chemical reaction is as follows. As mentioned in our introduction, In order for combustions to occur, fuel and oxygen has to combine with each other. As you can see in the diagram, CO2 will inhibit such reaction as CO2 is denser than oxygen, sinking beneath the O2 layer and forming an inhibiting layer between O2 and the fuel. This CO2 layer will prevent the oxidation reaction of CO2 extinguishing the fire. So
That's the concept behind the jumping flame experiment. So thank you and goodbye.